My goal in this video is to really get you to understand what it means to do a hypothesis test when we're comparing two independent samples that come from two different groups or two different populations, and we're testing to see if there is a real difference between the two groups. So, is the difference statistically significant? Is it really different? Or are the differences that we see just in our sample data just due to chance? So we never want to make it a conclusion based off of chance. We want to make sure that any differences that we see in the two groups is a real difference, that they are statistically significant. So to do this, I want to refer back to that freshman 15 study to add some context. So we're going to take a look at three different scenarios that represent the three different types of tests that you can do when you're doing a hypothesis test. But this is also relevant if you're building confidence intervals to test the claim. So first thing that we need to do is we need to define our two groups, which are called the two different populations. So let's let population one be the mean weight gain for freshman men, okay? And then let's let population two be the mean weight gain for freshman women. Then using the notation mu sub 1 is the mean weight gain for freshman men. And then mu sub 2 is the mean weight gain for freshman women, okay? So let's suppose that we want to test the claim that, and then it's this one right down here. We want to test the claim that on average, freshman men's weight gain is just simply different from freshman women's weight gain. So are they just different? So what we're going to do to test this claim is let's take the original claim. So this is the original claim. And then let's rewrite it using symbols, okay? So in symbolic form, what we're saying here is that mu1 is just different from mu2. So notice that this claim does not have the equal sign in it. So when we write our null and our alternative hypothesis, actually, let me give myself a little bit more space here. So the null and the alternative hypothesis, the original claim here becomes the alternative hypothesis. So anytime the alternative hypothesis contains that not equal sign, that means that you have a two-tailed test. Two-tailed test means if we're testing at a significance level of alpha, so if this is your significance level, then we're going to split alpha equally, and the left tail of our sampling distribution on the left here is going to have an area of alpha divided by 2, and then the area on the right tail, right? The area here is going to be also of value of alpha divided by 2, okay? The null hypothesis is always the claim that mu1 is equal to mu2, so it always has that equal sign. We assume that there is no difference. We assume that the mean weight gain for men and women are the same, and then we try to gather evidence to support the alternative statement, okay? All right, what does this mean in terms of checking to see if there is a true difference, if a difference really exists? So in terms of differences, I'll write it in blue here. When we say that mu1 is equal to mu2, what we're really saying is when I look at the difference, so difference means the answer to a subtraction problem. If I subtract mu sub 2 from both sides of the equation, I hope that you can see here, this is just some basic algebra, that the difference is equal to 0. So if this statement is true, then mu1 minus mu2 should equal 0. So that means that if I take the mean weight gain for men and subtract it from the mean weight gain for women, that difference should be 0. Okay, let's take a look at what the alternative statement means in terms of differences. So if mu1 is not equal to mu2, then when I subtract them and look for the difference, we see that the answer, or the difference, is going to be a number that's not equal to 0. So what does it mean to be a number that's not equal to 0? Well, that means that the number, or the difference, is either going to be a negative number or it's going to be a positive number, okay? It's just not going to be 0 because 0 is not negative or positive. I want to also kind of talk about this bell-shaped curve here on the normal distribution. At the center of this distribution is where we find the null hypothesis claim, or the null hypothesis value, mu1 equal to mu2. And if we're talking about differences, then on this bell-shaped curve at the center, the difference is 0 if we're at the center of the distribution. If we find out that the difference between the men's weight gain and the women's weight gain is a negative number, then we're going to see that that test statistic is going to fall on the left side of the distribution. And then if the difference between the men weight gain and the women weight gain is a positive number, then we're going to see that that difference is going to fall on the right side of the tail. So this kind of leads to the second scenario. In the second scenario here, let's change the claim that we're trying to test, and let's change it slightly so that we're testing the claim that on average, freshman men gain less weight than freshman women. So keeping track, this is our original claim. Let's write this in symbolic form. So here we're testing the claim that on average, the men's weight gain is less than the women's weight gain. Okay, so again, notice here we have that less than sign. So anytime that we have so first of all, let's go ahead and write the null and the alternative hypothesis. Okay, so because the original claim does not have the equal sign, this becomes the alternative hypothesis, mu1 less than mu2. And anytime that the alternative hypothesis has that less than sign, this means that we have a left tail test. So again, if alpha is our significance level, then the critical region that contains an area of size alpha is going to be all on the left tail of the sampling distribution. So all of alpha is going to be on the left tail. The null hypothesis, again, is always the claim that mu1 is equal to mu2. So in terms of differences, again, I'll write it in blue on the side here. So in terms of differences, we already talked about this, all right? If mu1 is equal to mu2, that means that the difference between the two population mean values should be equal to 0. At the center of our bell-shaped curve at the bottom, that is the null hypothesis value, that mu1 is equal to mu2. Or if we look at it in terms of differences, that would be where the difference is equal to 0. In the alternative hypothesis, when we make the claim that mu1 is less than mu2, if I were to subtract and look for the difference, mu1 minus mu2, we're saying that that difference is less than 0. So what kind of numbers are less than 0? Numbers that are less than 0 are our negative numbers, okay? So those are negative numbers. So if the difference between the two population means is less than 0, we should find that test statistic on the left side of the distribution, so on the left tail. Okay, let's now take a look at the third scenario. So here, notice that I changed the claim again. I changed it slightly, and now we want to test the claim that on average, freshman men gain more weight than freshman women. So again, keeping track that this is the original claim. Let's write this using symbols. Okay, so here we're saying mu1 is greater than mu2. Let's go ahead and write down the null and the alternative hypothesis. This claim is going to be the alternative hypothesis because it does not contain that equal sign. And then anytime that the alternative hypothesis has that greater than sign, this means that you have a right tail test. So again, if we're testing at a significance level of alpha, then this means that all of alpha is going to be on the right tail. So the region, the critical region on the right tail is going to have an area of size alpha. Okay, and then let's go ahead and also go ahead and write down the null hypothesis. So again, the null hypothesis is always a claim that the two mean values are the same or are equal to each other. So once again, if we're looking at the difference, so we want to know, is there a real difference? This means that when I subtract the mean for the men from the mean of the women's weight gain from the men's weight gain, right? If they really are equal to each other, we expect that difference to be 0. On our distribution here, if the null hypothesis value is true, we expect that to be at the center of our distribution where the difference is 0, okay? But if our data supports that alternative claim, okay, here, that alternative claim is saying that the difference between mu1 and mu2 is going to be a number that's greater than 0. So what numbers are numbers that are greater than 0? These are your positive numbers, okay? So positive values are going to be on the right tail of the distribution because those are numbers that are bigger than 0. And so I hope that this really helps you kind of understand what it means to have differences that are 0, negative, or positive. And then you'll see that understanding whether or not these differences are 0, negative, or positive is going to really matter when you're testing, when you're doing a hypothesis test for 2 independent samples and you're using the confidence interval method instead of a hypothesis test to test the claim. So there are 2 main ways of testing for differences in two population parameters. One way is to do a hypothesis test, and the other way is to do a confidence interval. Okay.